Assalamualaikum. My name is Muhammad Zuhairi bin Azman with matrix number DN180061. I will present about my research on bleaching for bamboo fiber using enzyme from food waste under my supervisor, TS Dr. Nasrul Fikri bin Cepa. So this is my poster that include information about this research. Basically, this research is to study the effectiveness of enzyme as natural bleaching agent to substitute hydrogen peroxide. The use of synthetic fiber has caused various environmental problems because carbon and glass fiber are not readily biodegradable and add as pollutant to the environment. Natural plants such as bamboo was introduced to replace synthetic fiber, hence the need for bleaching. This research is aimed to study the effect of natural bleaching agent known as enzyme on bamboo fiber and compare the result with conventional bleaching agent. The most suitable condition for enzyme was analyzed and discussed throughoutly. Bamboo fiber were bleached with enzyme in different temperature and bleach time accordingly and further oven dry at 40 degrees Celsius to 48 degrees Celsius. Tensile strength and the whiteness of the resulting bleached fiber are analyzed. Both parameters on the bleached fiber significantly improved compared to untreated fiber, with tensile strength increased 64% at temperature of 35 degrees Celsius to 50 degrees Celsius and 60 to 90 minutes bleaching, whereas for whiteness it increased 21% at in temperature of 50 degrees Celsius and 60 minutes of bleaching. In conclusion, enzyme provide better result compared to hydrogen peroxide in terms of bleaching duration at considerably low temperature. Because of environmental concern, fossil fuel depletion and climate change, there was a growing concern that natural plant fiber should replace synthetic fiber in polymer composite. The low density, thermal insulation and mechanical properties, low price, durability, sustainability and biodegradability of natural plant fiber are the main factor that attract its users. The creation of bamboo fiber for textile has some advantages. Bamboo fiber are an environmentally beneficial fabric derived from bamboo, which is renewable, fast-growing, degradable, and does not take up any cultivate land. Natural and regenerate cellulose fiber are widely bleached with hydrogen peroxide, but this method show in substantial energy consumption and severe fiber damage. So, this study is conducted to substitute hydrogen peroxide with enzyme that is multipurpose liquid where it is produced from the fermentation of organic waste. The organic solution of the simple fermentation of fresh vegetable and fruit waste with brown sugar and water produce enzyme. The problem of this study are the majority of bleaching agent contain hydrogen peroxide and are based on chemical detergency processes, but it affect the environment where it will release effluent that can be toxic and hazardous. Other than that, solid waste management is also a big environmental issue in Malaysia. It is because urban people consumption patterns have changed and caused an overabundance of municipal solid garbage. So, the objective of this study are to produce bamboo fiber from Semelian bamboo. Second, to analyze the effect of temperature and bleaching time for enzyme on bamboo fiber, to study the tensile strength of bamboo fiber after bleaching process, to study the effect of color reduction of bamboo fiber. Bamboo has a number of advantages over other forestry species, including its versatility, rapid growth rate, and ability to harvest numerous times in a few years. Another advantage is used as a high-yield renewable resource that is both affordable and abundant around the world for a variety of industrial applications. In bamboo fiber, there are three main properties which are cellulose, lignin, and cross-linking glycan. The diversity in the orientation of cellulose fabrics with respect to the longitudinal cell axis within various cell wall layers is an essential aspect of the ultrastructure of the wall. Lignin keeps the cellulose microfiber together by filling the void in the cell wall between the cellulose, hemicellulose, and peptide component. Cross-linking glycan, in addition to be a common matrix component of secondary walls, play an important role in preserving the structural integrity of the wall due to their close interaction with cellulose microfibers. There are a lot of application bamboo fiber such as in textile, musical instrument, concrete, and paper industry. So there are also many conventional bleaching for bamboo fiber such as sodium hypochlorite, sodium chloride, and the most commonly used is hydrogen peroxide. Enzymes are largely protein and peptide that are biodegradable and quickly removed from contaminated stream. They do not present any disposal issue. The use of natural catalysts such as protein enzyme to execute chemical transformation on organic substance is known as biocatalyst. In this study, the bamboo fiber will be bleached using enzyme treatment that known as ecoenzyme. As shown in the table, the properties of ecoenzyme are properties where it is the common conventional enzyme in the detergent business remove protein stain. Besides that, it has amylase that used to remove starch residue from meats. It is also have lipase that can remove fatty stain from collars and cuff such as fat, butter, salad oil, sauces, and even though stains. Lastly, cellulase change the cellulose fiber structure from cotton and cotton mixes, and it result in color brightening, softening, and film removal when added to a detergent. There are a few methods and conditions used in this study. This is the overview of the methodology started from the production of bamboo fiber until gain a suitable condition to use ecoenzyme for bleaching bamboo fiber. So for the preparation of bamboo fiber, the purchased bamboo strip are soaked in water for 3 to 7 days to soften it. After the soaking process, the bamboo strip separate according to the thickness and tightening the thick bamboo strip with machete. The thin bamboo strip are subject into bamboo fiber extraction machine or decorticator. The produced bamboo fiber will undergo combing process to remove the unwanted firm fiber and produce soft fiber. The fiber produced is shown in the figure. After the bamboo fiber obtained, the bleaching will go through with two conditions which are different temperature and bleaching time. In bleaching process, 40 ml of ecoenzyme was used and dilute with 1000 ml of distilled water. The solution was stirred to mix it well. Then the fiber were soaked with ecoenzyme and placed it in water bath with condition as shown in the table. All of the bleached fiber will be analyzed in terms of tensile strength and brightness and observe the most suitable condition for ecoenzyme to be used as bleaching agent for bamboo fiber. The whiteness of fiber was tested using colorimeter. Meanwhile, the tensile strength was tested using universal testing machine. Both machines can be obtained in UTHM laboratory. The objectives for successfully bleach the bamboo fiber using natural bleaching agent, which is ecoenzyme, are measured through method mentioned in methodology by using tensile strength and brightness of the bamboo. Based on the result for tensile strength, sample 1 at temperature of 35 degrees Celsius with bleach time of 60 minutes show a huge increment of 194 compared to untreated bamboo fiber. However, the tensile strength start to drop significantly when the bleach time increase for each temperature. There is an aspect of reason which can be explained for the result. The deterioration of tensile strength is caused by extension bleach temperature and time to some extent, which result with interaction between molecules. Hence, the tensile strength decrease when the treated fiber were over 50 degrees Celsius. The longer the bleaching time and the higher the temperature, the lower the tensile strength. Sample 9 was the test at the highest temperature, 70 degrees, and the longest bleach time at 120 minutes resulted the lowest tensile strength of 79.36 MPa. High tensile strength of treated bamboo fiber with ecoenzyme were due to the high load imposed to the fiber. Therefore, the suitable condition for better result in tensile strength using temperature between 35 degrees Celsius to 50 degrees Celsius, bleach in range of 60 minutes to 90 minutes. For the brightness, the data have three readings, which are lightness, redness, and yellowness of the sample. The method start with the control sample, where it acts as a reference to compare bleached fiber with the control sample. The lower in lightness value indicate the sample is darker. The lightness of the bamboo fiber was increased when it bleached with ecoenzyme, while sample 1 showed the increasing of 9.13 when using different sample and different bleach time with constant temperature of 35 degrees Celsius. It showed that the lightness was increasing. The highest value in lightness was sample 4, where the bamboo fiber was bleached with condition of temperature 50 degrees Celsius and bleach time was 60 minutes. From that, it showed that the ecoenzyme helps in increasing the brightness of the bamboo fiber with helps of temperature, but the value of lightness start to drop from sample 5 to sample 9 when the temperature and time increase. most enzymes prefer a temperature of around 37 degrees Celsius. As a result, the temperature at 35 degrees Celsius was where enzyme began to activate, and the temperature at 50 degrees Celsius, the protein began to degrade. Thus, the range of coenzyme activity is between 35 degrees Celsius to 50 degrees Celsius. The graph shows the trend of lightness at different temperature with constant bleach time with 60 minutes. From previous study, the brightness of bamboo fiber using ecoenzyme was higher than hydrogen peroxide at temperature 50 degrees Celsius, where the value of brightness for fiber bleached with ecoenzyme was 74 compared to hydrogen peroxide 20. The effect of hydrogen peroxide concentration on whiteness was rather mild because hydrogen peroxide is not particularly active in short bleaching times and temperature below 59 degrees Celsius. Therefore, suitable condition is using temperature 50 degrees Celsius with bleaching time 60 minutes for the brightness of the bamboo fiber. To be concluded, the treated bamboo fiber had been tested on its tensile strength and brightness to observe the effectiveness of ecoenzyme on bamboo fiber. From the result and discussion, the best condition of bleaching bamboo fiber using ecoenzyme is by using temperature around 35 degrees Celsius and 50 degrees Celsius and bleaching time of 60 minutes. It is because the result showed that ecoenzyme start to active at the condition mentioned. For the recommendation, it should be tested with different amounts of ecoenzyme in dilution to see more about the effectiveness of ecoenzyme on bamboo fiber. Besides that, future study can explore more about the addition and reaction of other natural enzymes with ecoenzyme in bleaching process. It can compress either using one enzyme or more natural enzyme have more effectiveness in bleaching bamboo fiber. Here are some of my references as a guide for my research. Here is the planning activity of Gantt chart for my PSM2. So that's all for my presentation. Thank you.